Hello students, welcome back to my YouTube channel. I am Shlok Kulkarni and today we are going to start our next quiz for December 2024. So far we have done so many quizzes and we have done so many questions of different types from MET, REGS, NAV, Tech. I hope you have understood them. You have learned how to answer the questions through conceptual understanding. So this is the goal of this daily quiz, that you answer different types of questions in one attempt. So at one time you are answering MET, then you are answering REX question, NAV question, Tech question. In DGCA I know that you will be giving papers separately, MET paper separate, NAV separate, Tech separate, so on and so forth. But when you go for airline exams, so there will be one paper which will be a mixture of or a combination of MET, NAV, REX, Tech. So this daily quiz is helping you in the long run to answer variety of questions in one attempt only, because this will help your memory and brain to recall many items, okay, in a complex scenario. So let's start with today's daily quiz. So question number 1 for today will be: the atmosphere pressure decreases with height at the following rate. So they have given three rates: 1 millibar per 40 feet, 1 millibar per 60 meters, and 1 millibar per 8 meter. So at what rate does atmospheric pressure decrease with increase in height? So the answer is, as you all know, 1 millibar equals to 27 feet. Sometimes we take it to be equal to 30 feet for easy calculations. Okay, this is the answer in feet. Now if we want to convert this in meter, we have 1 feet or 1 foot equals to, correction, 1 meter equals to 3.28 feet. Okay, 1 meter equals to 3.28 feet. So how many meters will be equal to 27 feet? So cross multiply 27 divided by 3.28. So that will give you an answer of 8.2 something something. Okay, so 27 feet is equal to 27 feet equals to approximately 8 meters. So you can say there are two ways of answering this. 1 millibar equals to 27 feet is the rate at which your atmospheric pressure decreases with increase in height. Or you can also state the same thing in terms of meter and write it: 1 millibar equals to every 8 meters. 1 millibar equals to every 8 meters. So remember this. So the correct option here will be option number Charlie, which is 1 millibar equals to 8 meters. If you forget this, either of this identity, you can use this conversion process and obtain one from the other. Question 2. Meridians are rhumb lines. This is what statement 1 says. Statement 2 says parallels are rhumb lines. Parallels are rhumb lines. So let's observe statement 1. Let's check statement 1. So it says meridians are rhumb lines. So over here currently now you have two meridians in front of you. So there are all these meridians drawn. Now for every meridian there will be a particular anti-meridian. So let's take for the current example. Let's take this meridian. After reaching North Pole, there will be a corresponding anti-meridian for it. Okay. So this is its anti-meridian. So anti-meridian, and this is your meridian. Okay. Now when your aeroplane travels from one meridian in the northerly direction, let's take an example where your aeroplane is traveling along this meridian in the northerly direction. So it starts from here, it goes in the northerly direction up to the North Pole, up to the North Pole. After flying along this particular meridian on a northerly heading, it will after some time reach the North Pole. After reaching North Pole, it will continue its flight in the same direction. It will continue its flight in the same direction on the opposite side of the hemisphere, which is along the anti-meridian. Along the anti-meridian. And this is your South Pole, okay? So what happens when it crosses the North Pole and continues on the opposite side of the hemisphere on the anti-meridian? Now the direction of flight will be what? When going northerly direction in this hemisphere, when going towards the North Pole, the direction or the heading of that plane would be north. 360 heading or northerly heading. After crossing North Pole and going on the other side of the earth, on this anti-meridian of this meridian, okay, it will be flying down towards what direction? South Pole. So the direction of flight after crossing North Pole will be southerly direction. So here you have northerly direction, here you have southerly direction. So what has happened to the meridian? So along this meridian, okay, as long as you start from the South Pole and you fly, and then you fly along this meridian up to the North Pole, your direction of flight will be the same. After crossing North Pole on the anti-meridian, the direction will change to southerly direction. But as long as you are flying on this particular anti-meridian, your direction of flight will be the same, which is southerly direction. Now, what is the definition of rhumb line? Rhumb line states that what is rhumb line? A line of constant direction, or any meridian, okay, or any flight path which has a constant direction, that will be called a rhumb line. So a line of constant direction is your rhumb line. So your flight direction should have a constant direction. It should not change its direction from north, then 30 degree, then 60 degree. Okay, so it should have same direction along its flight path. Now here the question states that the meridian, they are talking about meridian. So now if we just take this particular meridian, okay, ignore the anti-meridian, only if this particular meridian, on this meridian you can either fly northerly direction or you can or southerly direction. If you select to fly northerly direction along this meridian, your direction of flight will be same until you reach North Pole. If you select to fly a southerly direction, your direction of flight will be southerly, okay, until you reach the South Pole. So along a particular meridian, just the meridian, not the anti-meridian, the meridian, okay, the direction of flight will be constant. Therefore, our meridians will be called rhumb line, because along a particular meridian, either way you go, your direction of flight will be same. Now, if you consider meridian and anti-meridian, both meridian and anti-meridian together, okay, a meridian at North Pole, South Pole, and its corresponding anti-meridian. If you consider both of them together, so both of them together will not be a rhumb line, okay, because after flying along a particular meridian, when you go to its anti-meridian, the direction of flight changes automatically. Okay, after crossing North Pole, now your magnet will start pointing towards South Pole. So meridian and anti-meridian together will not be a rhumb line, but a meridian and its anti-meridian together will be a great circle, but not a rhumb line. Okay, so now in this question they are only talking about a particular meridian. Now this meridian can be this one particular meridian or this particular meridian, any meridian on the earth. So on that meridian your direction of flight will be same as long as you fly along that meridian. Okay, after that let's go to statement number 2. Parallels are rhumb lines. Parallels means parallel of latitudes. They are rhumb lines or no? So in this figure you can see 90-degree latitudes in the northern hemisphere and other 90-degree latitudes in the southern hemisphere. You have 0-degree equator. Okay, so what are rhumb lines? Again, rhumb lines are lines of constant direction, right? So that means when you fly along a particular latitude, any latitude you take, if you fly along that particular latitude, the direction of flight must be same. Now let's take 20-degree latitude, 20-degree north latitude. Now in this case, if you are flying along a 20-degree north latitude and you are maintaining that latitude throughout the duration of your flight, you can either fly an easterly direction like this. You can either go in the direction of east or you can go in the direction of west. Okay, in either way, you select any direction of travel. Okay, if you continue easterly direction, okay, and maintain that direction throughout the duration of flight, so you will make a 360-degree around the earth on at what latitude? At latitude of 20-degree north. So constant direction of east and east, and you can keep doing 360-degree rotation of the earth at that particular latitude in at that constant direction of easterly, provided you have sufficient fuel in the tanks. Or you can travel westerly direction and keep going westerly. Okay, if you keep going westerly, sooner or later you will be completing a 360-degree rotation around the earth at 20-degree north latitude. So same. So rhumb lines have constant directions. So same thing, parallels of latitude you can see, they have two constant directions, east and west. Okay. So by definition, therefore, parallels of latitude can also be called rhumb lines because they follow the definition or the rule that that rhumb lines have constant direction. And we can see parallels, any parallel of latitude from the north pole to the south pole along with equator will be a rhumb line, a line of constant direction. So by definition, both things are correct. So statement 1 is correct, statement 2 is also correct. Next, question number 3. Altimeter always measures the vertical distance of aircraft from where? Okay, we all know that altimeter always gives us vertical distances. It can be altitude, height, pressure altitude, flight level, QNE. Okay, so this vertical distances are measured from what kind of datum is the question asking. Is it above mean sea level always, 1013 pressure datum, or any datum at which its subscale is been set to read 0? Okay, to read 0. So before I begin this concept and explanation, I will suggest you to watch the videos that I have made on altimetry chapters. So there is a playlist made on altimetry questions from Oxford Met, in which I have solved all the back questions from altimetry chapter, Oxford Meteorology. So in that I have again and again explained this concept, okay, and also answered the questions. Another playlist, knowledge series playlist, in which I have explained barometric errors and temperature errors of altimeter. So from that also you will learn this part. So coming back to this, now your altimeter in your aircraft has a window called altimeter pressure setting window. In this window, you will always put an input of whatever pressure setting is outside your aircraft. If you are flying below transition altitude, you will put local QNH. If you are flying above transition altitude, okay, you will be putting standard pressure setting 1013 inside it, okay, in it. And if you want to, if ATC asks you to put QFE setting in it, you can also put QFE in the pressure setting window. So this altimeter pressure setting window is used to give an input of whatever pressure setting is existing outside or you have been instructed to use. Now whatever pressure setting you put in the altimeter setting window, be that QNH, QFE or 1013, the vertical distance indicated by your altimeter will be based on that pressure setting. So let's say, what I mean to say is, let's draw this. This is your airport ground surface, and the pressure existing at airport is called QFE, aerodrome level pressure. Then aerodrome level pressure reduced to mean sea level, meaning aerodrome level pressure converted to mean sea level gives you QNH pressure. And then we have 1013 or standard pressure setting of ISA. We call it SPS or standard pressure setting. So these are the three pressure data that I have used for this example. Similarly, I have used three aircraft. Okay, the purpose we will see of them. So let's start with aircraft 1. Now over aircraft 1, I have considered that aircraft 1 has put QFE pressure setting in the altimeter setting window. So the pilot of this aircraft is flying based on QFE pressure setting. Based on QFE pressure setting. Aircraft 2 pilot has put QNH in the window, and aircraft 3 pilot has put standard pressure setting 1013 in his altimeter setting window. So what does the rule say? The rule states that the altimeter indicates vertical distance based on the pressure setting in the altimeter setting window. Okay, based on the pressure that you put in the pressure setting window. So now in this example you have aircraft 1 which has QFE pressure setting in it. So for this particular aircraft, the vertical distance will be measured from the QFE pressure datum. From QFE pressure datum. That means the pressure datum of QFE will be the starting point. So this will be the starting point, that is 0 foot. So from this your vertical distance will be measured, and that vertical distance is called height. Vertical distance based on QFE is called height. Next we have aircraft 2 based on QNH, which has QNH setting in it. Now the vertical distance indicated by this altimeter will be starting from QNH pressure datum or mean sea level. Or mean sea level, we call it altitude. We call it altitude. Okay. So in this case, in case of altitude or QNH, your mean sea level will be the starting point, and therefore this will be your 0 feet. In case of aircraft 3, which has standard pressure setting in the altimeter window, the vertical distance will start from 1013 pressure level. We call it flight level. We call it flight level, and for this will be the starting point. So 0, 1, 2, 3, 4, so on and so forth up to this flight level. Okay, so the correct option will be what? In this case, from this concept, the correct option will be option C. It will start above datum level at which your subscale has been set to read 0. So whatever setting you put, from that datum level it will start measuring. Not from mean sea level or 1013. Depends what setting you put inside it. Next, question 4. The control surfaces used to produce or control pitch, roll and yaw respectively are what? Pitch, roll and yaw. Now what is pitch? Before we do that, so pitch. Pitching is a maneuver of aircraft in which the nose of aircraft goes first. It can go above the horizon. In simple words, above the horizon or below the horizon. Below the horizon. Okay. So above the horizon during climbing attitude, below the horizon during descent, maneuver, and in line with horizon somewhat when flying straight and level, when flying straight and level. So this is called pitching. Pitch up, pitch down, pitch more up, pitch more down. These are the terms that your flight instructor will always use when he starts teaching you. So in if I when let's draw a diagram. Let's say this is your horizon. In case you want to pitch up, your the cockpit of aircraft will look something like this. Okay, this is your cockpit of aircraft, and you are looking and you are sitting inside the cockpit, and now you are looking outside. So there is horizon in front of you, in front of your eye level. So in case you want to pitch up, in case you want to climb your aircraft, you will pitch up, okay, or you will raise the nose of your aircraft some 3 to 5 degrees above the horizon. Okay. So in case now there are two ways you can pitch up your aircraft, or you can check the pitch up attitude of your aircraft by looking at your instrument in front of you, which is your attitude indicator or artificial horizon. But if you are flying VFR, in starting you will learn to fly using your eyes and senses only. So you can just look outside your window and you can check that visually that your aircraft nose is 3 degree to 5 degree above the horizon. So this will be your climbing attitude in case you want to climb. Let's say you want to pitch down below the horizon. So in that case, the cockpit will look something like this. Okay, it will look something like this. Okay, so it is below the horizon. So when you pitch down below the horizon during, let's say during a descent maneuver, you want to come down closer to the ground for approach and landing. So in that case, you will be able to see the ground. You will be able to see buildings in front of you, houses, everything that is in front of you. Basically, when you pitch down below the horizon, the ground surface will be visible to you. When you pitch up above the horizon, all you will be able to see is clouds in front of you. So there is not much to see. Okay, but when you pitch down, there is plenty of ground surface that is visible to you. And the next thing is about your, so this is descent. And the next maneuver will be straight and level. So in that case, let's say if this is your horizon, the cockpit of your aircraft will be somewhat in line with this horizon. So you will be able to see a little bit of ground surface in front of you and a lot of sky above you. Okay, so this is the straight and level picture when you are flying straight level. Okay, so pitching is the nose of aircraft goes up or down the horizon, pitch up, pitch down, pitch more up, pitch more down. Okay, and then when you are straight and level. Next, let's go to roll. Now, what is rolling of aircraft? This is another maneuver in which your aircraft will bank. The wings of aircraft will rise and fall. So one wing rises, the other wing and the other wing falls. So that means you want to turn your aircraft. You want to turn your aircraft. Okay, so if you want to make a left turn, your left wing will go down and the right wing will go up, and that's how you will turn towards left. If you want to make a right turn, that is a right roll, so you can again, your right wing will go down and your left wing will go up. So this is how you will make a right turn. So this is the rolling maneuver of your aircraft, in which the wings of aircraft, one is lifted up, another is pulled down, and this is called rolling or banking. Okay, next is yaw. Yaw is that maneuver in which your nose of aircraft moves left moves or swings left or right. Okay, nose of aircraft swings left or right. Let's say this is your horizon, okay, in front of you, and this is the straight line. So if you want to yaw left side, in that case, your aircraft will go left. Okay, it will yaw left. The wings are level. Wings are level. This is not a roll. This is just a yaw. Wings are level. Okay, you are just turning the nose of your aircraft left or right. If you want to make a right yaw, again, if this is your horizon, this is your reference line. So if you kick the right rudder, with the help of right rudder, you can turn your aircraft the other way around to the right hand side. Okay, so the nose has turned right. So right yaw, left yaw. Okay, wings are again level. Wings are again level. So this is the yaw maneuver of aircraft. So next, let's come back to the question once we have revised this basics. The pitch, roll and yaw. So what control surfaces on your aircraft? Okay. So how is pitch generated, or how is roll produced, yaw produced? So what control surfaces on your aeroplane do that? So we have three primary control surfaces. Primary control surfaces and the results that they produce. So first one is your elevator. Your elevator. Now you can see elevator is on the trailing edge of horizontal stabilizer. Your elevator is on the trailing edge of the horizontal stabilizer. So this portion, this small wings, okay, are called horizontal stabilizers. And the portion towards the back, the yellow shaded portion, that is called trailing edge, which is at the back. And there is a control surface which is movable, and that surface is called elevator. So elevator is the first primary control surface, the very important surface, and it produces pitch. So we can pitch up or pitch down with the help of elevator. Second surface is aileron. Aileron. So these ailerons are located on your main wings. And where are they located? On the main wings, on the trailing edge, that is behind the on the backward section of the wing, that is your trailing edge, towards the wingtip. So this is where your ailerons are located. So you can see they are located at the trailing edge behind the wing, okay, and towards the wingtips. These are your wingtips. So behind and towards the wingtips. Okay, so both ailerons. Similarly, elevators are also located on both sides. An aileron will roll your aircraft or bank your aircraft. Last control surface is rudder. And this same control surface also exists in the ships. Okay, so rudder, it produces yaw. Which is the left turn or right turn of the nose of your aircraft. So rudder is located on the trailing edge of vertical stabilizer, on the backward portion of the vertical stabilizer. So the correct option will be pitch is produced by elevator, roll is produced by aileron, and yaw is produced by rudder. So option A is the correct option. And also check the sequence: pitch, elevator, roll, aileron, yaw, rudder. So also follow the sequence. Next question.